All right, in problem number 1, it asks us to simplify the expression, and for these problems you need to make sure you look at the symbol between the two parentheses, because then that'll tell you if you're adding, subtracting, or multiplying. So in this case we are adding these two polynomials. Remember that when we are adding polynomials we can essentially just ignore the parentheses and we just combine like terms. So starting with the highest degree exponent, we have 3x to the fourth, and since there are no other x to the fourth terms, we can just write 3x to the fourth. The next highest degree is x cubed, and there's only one x cubed term, so that's plus 8x cubed. And then we have our x terms. So this one we have 14x and negative x, so that makes plus 13x. And lastly, we have our constant term, which is plus 5. So there's a last term. All right, so problem number 2. Now we're subtracting. So remember, with subtraction, first thing we need to do is distribute that negative to all the terms in the second parentheses. The first parentheses stay the same. So 11x to the fifth minus 7x cubed. And when we distribute the negative, it basically switches the sign for every term. So negative 4x to the fourth plus 2x cubed minus 3x minus 15. Now we can go ahead and combine like terms like we did in the previous. So starting with the highest degree exponent, we have 11x to the fifth. And then the next term is x to the fourth. So we have negative 4x to the fourth. And then we have our x cubed terms. So we have negative 7 and positive 2. So that's negative 5x cubed. And then we have our x term. So negative 3x. And lastly, we have our constant term, which is minus 15. All right, problem number 3 is another subtraction problem. So again, like the previous one, we're first going to distribute the negative. So we have 6x squared plus 13. And then this becomes minus 4x cubed plus 14, since we're switching the sign to the second parentheses. And now we combine like terms. So starting with the highest degree exponent, we have negative 4x cubed. Then we have our x squared term, so plus 6x squared. And then we have our constants. 13 and 14 makes 27. All right, number 4, it says which of the following result in x squared minus 81? So what we need to do to determine this is we need to go ahead and multiply these out and see which one gives us x squared minus 81. So starting with a, I'm just going to use distributive property. So x times x is x squared. X times negative 1 is negative 1x. Negative 80 times x is negative 80x. And then negative 80 times negative 1 is positive 80. These two middle terms combine to make negative 81x. So it's x squared minus 81x plus 80. So it's not going to be a. Then b, x times x is x squared plus 9x minus 9x. And negative 9 times 9 is negative 81. And when we combine like terms, those cancel out. So I'm left with x squared minus 81. So that works, b. And I'm just going to check the last one just to be sure. X times x is x squared. X times negative 8 is negative 81 is negative 81x. So that's close, but since the second term has an x, it can't be c either. All right, problem number 5, it says what is the product of the polynomial? So what we're really doing here is just multiplying. And we're just going to use the distributive property. So 10x times 5x, 10 times 5 is 50. And then we have x times x, which is x squared. And then we have 10x times 12, so 10 times 12 is 120, and then we have an x. All right, number 6, it says find the area and the perimeter of the rectangle. So first starting with area. In order to find area, we need to multiply length times width. So we're just going to do 2x plus 2 times 4x plus 3. So for this one, you can either use the box method or you can use distributive property. So I'm just going to use distributive property. So 2x times 4x is 8x squared. 2x times 3 is 6x. 2 times 4x is 8x. And then 2 times 3 is 6. When we combine like terms, we get 8x squared plus 14x plus 6. So there's the area. To find perimeter, we need to remember that in a rectangle, the opposite sides are equal. So this is 2x plus 2, and this is 4x plus 3. So we're just going to combine like terms. So we could, if we wanted, write out the expression here, but since our terms are all the way up here, I'm just going to combine them up here. So adding up all the sides, we're going to add together our x terms, 2x, 4x, 2x, and 4x. So 4 plus 4 is 8, plus 2 is 10, plus 2 is 12. So it's going to be 12x, and then we're going to combine our numbers. 2 plus 3 is 5, plus 2 is 7, plus 3 is 10. So 12x plus 10 is going to be my perimeter. All right, problem number 7, it says what is the product of the polynomials? So again, we're multiplying, but in this problem, since it's a little bit bigger, I'm going to go ahead and use the box to multiply. So since we're multiplying a 2 by 3, I'm going to draw a 2 by 3 box. This is x and 11. And then we have 4x squared minus 3x minus 1. And then we're going to multiply. So x times 4x is 4x cubed. X times negative 3x is negative 3x squared. X times negative 1 is negative 1x. And then the second row, 4x squared times 11 is 44x squared. Negative 3x times 11 is negative 33x. And negative 1 times 11 is negative 11. Now we're going to combine like terms. So starting with my x cubed term, there are no other x cubed terms, then we can combine these terms. So 44x squared and negative 3x squared is 41x squared. And then I can combine these. That makes negative 34x. And then I have minus 11. All right, the next problem is number 8. We're finding the area of the shaded region. So in order to do this, we're first going to find the area of the larger shape. And then we're going to find the area of the smaller shape. And since we're just looking for the shaded area, we're then going to subtract them. So looking for the larger area, we're going to multiply x times 3x plus 4. So using distributive property, this is 3x squared plus 4x. And then the smaller area, we're going to multiply x minus 2 and x minus 1. So using distributive property, it's x squared minus x minus 2x plus 2. So that's just doing x times x times negative 1, negative 2 times x, and negative 2 times negative 1. And we get x squared minus 3x plus 2. And now to find the area of just the shaded area, we're going to do the larger area, which is 3x squared plus 4x, minus the area of the smaller region, which is x squared minus 3x plus 2. So in order to subtract, we're first going to distribute that negative to the second parentheses. So we get 3x squared plus 4x, and then minus x squared plus 3x minus 2. So remember, the signs just switch. And now we can just combine like terms. So starting with my x squared terms, 3x squared and negative x squared is 2x squared. And then I have 4x and 3x, so plus 7x. And lastly, I have my constant term, which is negative 2. So here's the area of the shaded region. All right, number 9, simplify the expression. So this one, remember, we do not distribute the exponent. What we need to do is we need to expand this. So it's 6x minus 10 times 6x minus 10. And then we can go ahead and just multiply either using the box or distributive property. So usually if it's a binomial times a binomial, I just do distributive property. So 6x times 6x is 36x. 6x times negative 10 is negative 60x. Negative 10 times 6 is negative 60x. And then negative 10 times negative 10 is positive 100. So combining like terms, we end up with, oops, this should be 36x squared. 36x squared minus 120x plus 100. All right, the next problem is Number 10 says, what is the greatest common factor for the polynomial? So to determine the greatest common factor, remember if you can't look at it and see, what you should do is you should list out all the factors of each term. So starting with 18. So 1 and 18, 2 and 9, 3 and 6. And then we're going to list the factors of 12. So 1 and 12, 2 and 6, 3 and 4. And then of 27. So 1 and 27, 3 and 9. So in scanning this list, we want to look for the biggest number they all have in common. And they all have a 3. So I know that my GCF contains a 3. So I know it's going to be positive because my leading term is positive. Next thing we do, we look at our variables and we look for our lowest variable term, which is x squared. So my GCF is 3x squared. So in this problem, I don't ask you to factor it. I'm just asking what is the GCF. All right, number 11 says completely factor the following polynomial. We're going to show all the factoring work. So any factoring problem, first thing we do is check for a GCF. So we have 8, 80, and 88. Since 8 is the smallest number, that's the biggest our GCF can be. And since 8 goes into 80 and 88, my GCF is going to contain an 8. And then looking at the lowest degree term, we have x cubed. So we have 8x cubed, and then remember we're going to divide everything by 8x cubed to get the inside. So 8 divided by 8 is 1, and then we're left with x squared. Negative 80 divided by 8 is negative 10x. And negative 88x cubed over 8 is minus 11. So since this is a quadratic leftover, we should be able to factor this more using the box. So I'm going to write this across the diagonal, x squared minus 10x minus 11. And we're multiplying to make negative 11, since we're multiplying our diagonals, and adding to make negative 10, which tells me I have to have a positive and a negative. So listing out my factors of 11, it's only 1 and 11, which means that has to be the pair. In order to make negative 10, it's 1 minus 11, so the 11 is negative. Now we can get the outside, so top row GCF is x, and then x times x gives me x squared, x times positive 1 gives me 1x, x times negative 11 gives me 11x. So my final answer, don't forget about the GCF, so 8x cubed, parentheses, x plus 1, and x minus 11. All right, number 12, we're factoring. So first thing we're going to do is check for a GCF, and in this case there is no GCF. One quick thing that will help you is if there's no number in front of x squared, there's not going to be a GCF. So then we can go straight to our box. So x squared plus 14x plus 48. We're multiplying to make 48 and adding to make positive 14. So since we're multiplying to make positive, adding to make a positive, I know that both numbers need to be positive. So listing out our factors of 48, it's 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. So those are my factors. So now we're going to look for the pair that gets us to be 14. And that pair is going to be 6 and 8. 6 times 8 is 48, and 6 plus 8 is 14. So this is 6x and 8x. Now to get the outside, we look at the top row. X squared and 6x, I can take out an x. X times x gives me x squared, x times positive 6 gives me 6x, and x times positive 8 gives me 8x. So my final answer factoring is x plus 6, x plus 8. All right, number 13, another factoring problem. So there's no GCF on this one too, just because there's no number in front of x squared. So then we go straight to the box, x squared plus 15x plus 36. We're multiplying to make 36, adding to make 15. So since we're multiplying to make positive, adding to make positive, it's going to be plus plus. And then we're going to list out our factors of 36. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So the pair that's going to get us 15 is going to be 3 and 12. 3 times 12 is 36. 3 plus 12 is 15. So 3x and 12x. And then we GCF the top row, x squared and 3x. We can take out an x. Then that means this has to be x. X times positive 3 is 3x. X times positive 12 is 12x. We should double check each of the boxes. This is x squared, 3x, 12x. 12 times 3 is 36, and then these add to make 15x. So our final answer is x plus 3 and x plus 12. All right, problem number 14, completely factor the following polynomial, show all factoring work. So in this case, you're going to need to be able to recognize this as being difference of two squares. 16x squared is a perfect square, and the square root of that is 4x. 49 is a perfect square, and the square root of that is 7. So remember, this factors as 4x plus 7 and 4x minus 7. This is difference of two squares. All right, number 15, we're going to factor and then we're going to find the solutions. So in order to solve by factoring, we need to have one side equal to 0, which we already do. So since one side equals 0, we can go straight into factoring. So looking at 3x squared minus 2x minus 8, there's no GCF. So I'm going to make my box. Okay, and then we are multiplying, sorry, this should say 8, negative 8. We're multiplying to make negative 24, adding to make negative 2. So since we're multiplying to make a negative, that means it's a positive negative. And then we're going to list out our factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And those are all the factors. So now since one's positive, one's negative, we're going to look for the pair that subtracts to make negative 2, and that's going to be 4 and 6. And it's going to be 4 minus 6. So 4 and negative 6 makes negative 2, and we multiply those, it makes negative 24. So putting these in the box, plus 4x and negative 6x, we're going to GCF the top row. 3x squared and 4x is just x. And then working backwards, x times 3x gives me 3x squared. X times positive 4 gives me 4x. 3x times negative 2 gives me negative 6x, and we should just confirm that 4 times negative 2 gives me negative 8. So now we have our factors, 3x plus 4 and x minus 2 equals 0. Now to solve, we're just going to set each factor equal to 0. So 3x plus 4 equals 0, and x minus 2 equals 0. So now we're going to solve. Subtracting 4, and then divide by 3. So x is negative 4/3. There's one solution. This one we just need to add 2. So x equals positive 2. All right, the next problem is another solve by factoring. So this one, first we need one side to equal 0, so we're going to add 48 to both sides. Since these are not like terms, we can't combine them. So now we have one side equal to 0. Now we're going to factor. So my GCF in this case is going to be 12. And now we're going to factor. So I have x squared plus 5x plus 4. We're multiplying to make 4. We're adding to make 5. Well, the only factors of 4 are 1 and 4 and 2 and 2. So 1 and 4 are going to be my factors. And then factoring the top row, this has to be x. This has to be x plus 1 and plus 4. So this factored 12 out in front. And then we have x plus 1, x plus 4 equals 0. And now we're just going to use zero product property. So we know 12 can equal 0, so we're just going to set these factors equal to 0. X plus 1 equals 0. Subtract 1. So x is negative 1. There's one solution. And then I have x plus 4 equals 0. I'm going to subtract 4 from both sides. So x equals negative 4. My dog is not happy that I'm doing this right now. All right, number 17 says, what are the exact solutions to the equation? So in order to solve this, so it doesn't say solve by factoring. So let's just see what would happen if we start moving terms over. So plus 4x. So I have x squared. So these actually cancel out. So I have x squared plus 18 equals 30. And remember, when our x term disappears, that means we can solve by taking square roots, meaning I can subtract 18, I can isolate my x squared term. So I have x squared equals 12, and then we can just take the square root. So square root of x squared, square root of 12. We're going to simplify square root of 12. So 1 and 12, 2 and 6, and 3 and 4. So we can rewrite this as the square root of 4 times the square root of 3, which is 2 times the square root of 3. So x equals plus or minus 2 times the square root of 3. All right, for the last problem, number 18, it says, what are the exact solutions to the equation? So this one I have a binomial squared. So remember, we're going to isolate our binomial. We're going to solve by taking square roots. So we're going to add 9 to both sides first. So I have k minus 9 squared. 42 plus 9 is 51. And then we're going to take the square root. So 51 can be written as 1 times 51 and 3 times 17. But in scanning the list, there are no perfect squares, which means we're just going to leave it as square root of 51. So I have k minus 9 equals plus minus the square root of 51. And then this is where we break it into two equations. So I have k minus 9 equals positive square root of 51, and then I have k minus 9 equals negative square root of 51. So now we need to solve, so we're going to add 9. So I end up with k equals 9 plus square root of 51. That's one solution. And the other one is k equals 9 minus square root of 51. There's my two solutions.